All right, so this next one we have a road test. So the accompanying table shows the time it takes for a Toyota Supra and a Porsche 911 Carrera to accelerate from 0 miles per hour to the given speed. So both of them have the same speeds, just different times to get there. Now find all models for each. Find a model for each car given the speed in feet per second. All right, so this is a key thing. This is a speed in miles per hour, and they want it in feet per second. So there's going to be a conversion when we do that as a function of the number of seconds after starting from 0 miles per hour. So include 0, 0 as a data point. So really there's going to be a 0, 0, and there's going to be a 0, 0. All right, so then how much further than Porsche 911 Carrera does the Toyota Supra travel during the first 10 seconds, assuming both cars have a standing start? And how much further than a Porsche 911 does a Toyota Supra travel between 5 seconds and 10 seconds? So first things first, how are we going to get our speed in the correct units? So what we're going to have to do is we're going to have to take our speed in miles per hour times, and let's go from 1 mile is 5,280 feet, and 1 hour is 3,600 seconds. Okay, so we're gonna have to take each of these, plug it in here, and so we'll take it times 5,280 divided by 3,600, and then we can put that in a table. So if we go over here, now I don't know if it actually shows up still as a calculation here. No, it doesn't. So I went ahead and took the 30 times the 5280 divided by that. And so I just did it right here in the thing. So that's one thing that's nice. So then we'll take that times our 5,280 divided by 3,600 to kind of show you that's what you can do. And it puts the number directly in there. And then if there's decimals, it keeps all our decimal places. So that's a nice thing. So now I've got my L1 and L2, or my X and Y for the Toyota, and then L3 and L2 are going to be my Porsche. So let's go and actually let's look at what it looks like here. Let's make sure there's actually, let's quit that, make sure there's nothing in here. Let's clear that out. And so it looks like we need to go further. We need to go, that should be all. That must be just how it goes. So we've gone further than we need to. All right. So what does it look like? Well, it looks like it could come up and maybe come back down. It could be some other things. So let's start with a quadratic. And let's put that into L1 or Y1. And so that's our equation. So let's see what it looks like on the graph. Yeah, that blue, it fits pretty good. I think that's what we're going to use. So now let's do the one for the red. And so we'll do stat, and it looks like it's going to follow the same thing. So now that's L3, L2. And let's put that into 2. And so we have that value. Okay. And again, what does it look like? So those are two things. So now let's write our equations down. So here for part A, I don't know, let's do a Toyota for time, and let's do the Porsche for time. All right, so Toyota we had was a negative 0.702x squared, and then plus a 20.278x, and then it was plus a 4.441, and then again, this is in feet per second because we had to have that. And it's going to be after basically, well, I put X here and I put T here. So let's change this to X because I know I'm going to write them both as X anyway. All right, so we'll have P of X now. So now what we have to do is go back. Oh yeah, we did that already. So I already showed you that. So we can just write it down. So we have here, we have negative 0.643x squared plus 18.963x plus 5.252, and again, feet per second. So now, that one's part A. So part B, how much farther did the Carrera go? Farther than Porsche does the Supra go? Okay, so assuming both cars have a standing start. Well, how are we going to do that? Well, what we could do is we could find area. Okay, and so because if we take the integral of both of those, that'll be feet, and that will give us distances each of them travel. So if we're going to assume that the Toyota goes further and it's going from 10 seconds, so 0 to 10, and if we say, okay, well, let's take t of x minus our p of x dx, that should give us the distance that this one is further. So this is going to be higher than this one, and we want to see what that distance between those two curves is. And so this time they didn't ask us to draw a picture, but we could go look, and it's slightly higher, that blue line. So it is going to have some positive value. So let's do our math. 9, 0 to 10. And we're going to do our alpha 1 minus alpha, actually, yeah, totally we put in first, 2, and then dx. And if not, what we'll have to do is just change it. So it looks like it went 17.964 or 65 feet longer. So this is 19.9 or 17, sorry, I'm writing 17 point, because I changed that 5 at the end, so I memorized something wrong. So 17.965, and that's in feet. And so that's how much further the Toyota went than the Porsche in the first 10 seconds. Now C, let's see if we can write that here and still get it on the same page. How much further than the Porsche does it go between 5 and 10 seconds? Well, it's going to do the same thing, except we're going to go from 5 to 10, t of x minus p of x dx. And so nice thing here, what we can do is we can just second enter, and all we're going to change is that to a 5. And so here it's 18.044. And so that's how much further it goes in the 5 to 10 second region. Okay, so we're going from here to just past that, and here we're going around here to just under that. Okay, so that's how much further it goes in the whole time, and then how much further it goes in just that half of the period. Okay, all right, so let's stop there and we'll go and come back in a second.